Hi guys, in this video I wanted to do a walkthrough of one of the most difficult A-level chemistry questions. So this question caused quite a bit of uproar when it came out. It was in the June 2011 OCR paper and it was responsible for a lot of complaints at the time. So in this video I wanted to do a walkthrough of this question and we can do a model answer together. So the question says, the magic tang in many sweets is obtained by the use of acid buffers. A sweet manufacturer carried out tasting tests with consumers and identified the acid taste that gives the magic tang to a sweet. The manufacturer was convinced that the magic tang will give the company a competitive edge, and he asked the company's chemist to identify the chemicals needed to generate the required taste. The chemist's findings would be a key factor in the success of the sweets. The team of chemists identified that a pH of 3.55 was required and they worked to develop a buffer at this pH. The chemists decided to use one of the acids in table 4.1, so they included that down here, and a salt of the acid to prepare this buffer. Deduce the chemicals required by the chemist to prepare this buffer. Calculate the relative concentrations of the acid and its salt needed by the chemist to make this buffer, and comment on the validity of the prediction that the pH of the sweet would give the sweets the magic tang. So if we break this question down further then, this first part is just setting the scene. So it's letting us know which topic the question is about. It's about acids, bases, buffers, pH. This bit of information, the pH, is important here, so I've highlighted that. And when it says calculate the relative concentrations of acid and salt, we need this equation. It's hinting that we need this. So concentration of the salt over concentration of the acid is equal to Ka over H plus. And we can get H plus from the pH. And in this table, we've got pKa's and we can get Ka from that. So let's start having a look at a model answer then. One of the first things we need to know in order to be able to answer this question is that pH is approximately equal to pKa, and buffers are most effective when the desired pH is equal to the pK plus or minus 1. So that difference of plus minus 1 means there's a 10 times difference between the acid and salt concentrations. So the question says the desired pH is 3.55. That means we need to look at the table and find an acid with a pKa that's closest to that value, and that is lactic acid. And remember, it says reduce the chemicals required, so buffers are made of a weak acid and its salt, so we can say we need lactic acid and sodium lactate would be the salt. Next we can move on to the calculation. So here's the expression that I mentioned earlier, and then to get Ka from pK we do the inverse log, or in other words 10 to the minus the pK value. Same thing for H plus as well, we can get that from the pH. We divide these numbers, and if this is the expression you use, you should come out with around 0.5. So that's saying that we need the salt concentration to be half that of the acid, which makes sense because a buffer needs an excess of the weak acid. Now you could have also flipped this whole expression, and if you used it like that, you'd come out with a value of 2.0, which means that you'd need twice as much of the acid compared to the salt, and you'll see that they're both saying the same thing, so either of those is fine. Now we're on the last bullet point. Comment on the validity of the prediction that the pH would give the magic tang. So I'm sure there are lots of different ingredients in sweets. I mean, if you look on the back of the packet, there are lots. So I think that statement is not valid because there are many other chemicals in the sweet which could influence the taste. So I've said it's not valid to say that pH alone is responsible for the magic tang.